Thank you. So, good morning, everyone. My name is Oliver Kastner-Hauler, and together with my colleague Karin Tengler, which should be right via in up here with us, we are investigating a project about computational thinking and this little gadget which you have big on the screen now called microbit. The BBC microbit is a single board computer which has a 5x5 LED display in front, and it helps maybe, and that's the interesting point which we are researching, computational thinking in school. Thank you. After 1 year, the BBC did a study, the first impact study, and there is definitely an increase in the interest of young people in computer science. If you look at this increase, especially the girls, they said before they had the treatment or the possibility to use the microbit in classroom, 23% of them used were choosing computational science, computer science as a subject, and now they have 39 after this first year. Well, computational thinking, it's just that we have the same things in mind, can be divided in those 4 quarters. It's breaking big problems into smaller ones so that they are achievable. Then maybe you recognize a pattern in these small problems. After that, you design an algorithm which is to solve your problem, and then you can also remove unnecessary parts, get a higher level overview for the abstraction to make a generalized solution. So, giving that just a recap of what we heard maybe yesterday, computer science and computer literacy is not the same. Look at this one down here. The description how to design a car or how to drive a car, these are the broken down differences. Or in terms of computer science, computer literacy cannot be learned without the computer. If you imagine some skills in Excel, in Word, in whatever program you have, but computer science can be learned totally without a computer. This is just for your information what the BBC microbit has all on board. Look at this. This is the CPU, the processor. You have accelerometer, you have radio antenna, Bluetooth, you have little connectors, large connectors like this 0, 1, 2, 3 that you can connect with crocodile clips. And from that on you go to the making part. So the programming of this little device normally works with the block-based programming language, but you can also in higher levels in secondary schools, you can use that even in JavaScript. Or if that's not enough for you, you can switch to Python. There's a little program that's called the MU editor, which you can use for programming in the Python language. So what this research or this project is about, every school gets 20 of these little devices compared with some tablets, and this book for a trolley for the power reloading. And this trolley travels after 2 months from one school to another. The project is about to be done in whole Austria for 3 semesters. And in the beginning, we wrote a book, which is an open educational resource, so you can download this book at this URL. You're welcome to do that. At this URL, we have a wiki, and this wiki explains in detail, but from a high level to a very detailed level, so that the pupil or the teacher can choose what instructions you like to use or to explore. So you don't get the step-by-step introduction. You get first an overview, do this and that, and if you don't, if that's not enough for you, you can zoom into the details. So what right now is on the way. We have this treatment in class, and before I do a pre-test as an online survey for the pupils, and after this treatment we will have a post-test. This is for the students, and what are they expected to do online with this test? They are presented 5 questions in different levels of difficulty and in different levels for the students. So for the secondary, 1st and 2nd grade, 11, 12 age, and for the 13, 14-year-old, they have different question banks. We selected from the Bebras, so in German it's the Biber of Informatik. If you know, maybe the kangaroo for mathematicians, so this is a similar project. What it does, it gives you a score. What the Bebras contest is thinking of would be good, and based on that score we can maybe measure things that happen after the treatment compared to the pre-test. For the teachers, we have an online survey to give feedback to the open educational resource book. They can give the feedback just for one example, for individual examples, or for the whole phase of the project in the classroom. This is implemented as an online survey, and also it's to be determined exactly what we will do, but I'm in kind of thinking it would be maybe necessary to have a qualitative interview to validate the data that came in from the feedback from the online surveys. So it's planned to have maybe in every region of Austria some interviews with teachers who gave us feedback. So this is the project right now. It started, and yeah, I would like to have your feedback. If you like to know more about the microbit, there are plenty of tons of materials out there. It's only in German, but if you have 15 minutes, you will get a good overview what I did with the microbit. Thank you.